Okay, so the question here is to find the smallest upper bound. Okay, well that's part of the process. What I really want to do is find x-intercepts, but I'll play along. Find the smallest upper bound. Well, here I'm going to write my numbers. -12, -6, -4, -3, -2, -1, 1, 2, 3, 4, 6, 12. Those are all my possibilities. So what I'm going to do is go for something in the middle here. All right, I'm gonna get a little greedy. I'm gonna go with 3. Let's see what happens when I put in a 3. It's possible 3 is going to give me a 0. I am kind of guessing and hunting for x-intercepts here in the long run. But this goes 1 for the x to the 4, 2 for x to the 3, -7, -8, and 12. Let's see if this 3 works. If the 3 works, that's great. I already made this smaller. So I bring down 1. 1 times 3 is 3. 2 plus 3 is 5. 5 times 3 is 15. -7 plus 15 is 8. 3 times 8 is 24. -8 plus 24 is 16. 3 times 16 is 48. And 48 plus 12 is 60. Well, look what happened. Positive, 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 positive. 3 is an upper bound. So what does that tell me? Don't bother looking for 4, 6, or 12. None of those could possibly work. 3 is an upper bound. Nothing bigger than 3 works. I just eliminated a lot of things to guess. So, might as well guess 1 or 2. Now here's the thing. Our Descartes' rule of signs for this problem told me I could either have 2 or I could have 0 positive numbers. I might be wasting my time. Maybe none of them work. But I'm going to put in a 2, and I'm going to see what happens. With that 2, I go 1, 2, -7, -8, and 12. All right, I'm going to draw my line. Bring this down, I get a 1. 2 times 2 is 2. 2 plus 2 is 4. 2 times 4 is 8. -7 plus 8 is 1. 2 times 1 is 2. And I'm going to stop right there. Look what happens. -8 plus 2 is -6. This is no longer an upper bound. My answer to this question is 3. The smallest upper bound is 3 because 2 is not an upper bound. It went negative. More than that, 2 times -6 is -12. I actually just found a 0 right here. Hey, some of my work is done. I found a 0. Now I'm going to find the largest lower bound. I do want you to see how that works also. So let's go with this lower bound scenario. I'm going to try a -4 just to see what happens, okay? So I'm going to put in the 1, 2, -7, -8, and 12. Maybe we find a 0, maybe we find a lower bound. If I was just looking for all of the zeros, by the way, I mean, I do want you to see how the lower bound works, but I would definitely be trying the 1 right now. Because Descartes' rule of signs said as far as positive real zeros, there's either 2 of them or there's none of them. It doesn't say it's possible to have 1 of them. And now that we know that that's not an option because we found one, there's another positive real 0. So there's no way I would be looking at negatives, which I might not be able to find one. I would go find that other positive real 0. I would try 1 right now and see if I find another one. However, since I'm supposed to look for lower bounds, I'm just going to follow the directions. So I bring down the 1, I multiply I get -4. I add these 2, I get -2. I multiply and I get +8. Add the -7 and 8, you get 1. -4 times 1 is -4. Add these 2, you get -12. When I multiply these 2, I get 48. And 48 plus 12, again, is 60. So -4, I could cross it off, is definitely not a 0, right? But now look at what happened. They alternate from positive to negative, positive, negative, positive. That's how the lower bound theorem works. Let me bring it over from the other page. If I'm putting in negative numbers, which I put in -4, and each coefficient alternates from positive to negative, including the one in the house, then it's a lower bound. It's not a 0, because I didn't get 0. It's a lower bound. So what I can do, I can cross off -6 and -12. I'm making the guesswork easier by using a couple rules to narrow down the options, right? So now I should try -3. Put in a -3, and I go 1, 2, -7, -8, and 12. Okay, bring down the 1. -3 times 1 is -3. 2 plus -3 is -1. -3 times -1 is 3. -7 plus 3 is -4. Stop right there. It no longer alternates. -3 is not a lower bound. Negative 4 was a lower bound. So the largest lower bound is negative 4. We just found that out. Let's keep going to see if this is a 0, though. Negative 3 times negative 4 is positive 12. Negative 8 plus 12 is 4. Uh-oh. Negative 3 times 4 is negative 12. We found another 0. We found 2 of the 4. One of them positive and one of them negative. I'm going to bring the other sheet over again. If we found one positive one, we're going to find a second positive one. If we found one negative one, we're going to find a second negative one. There are 2 left out there. This x to the 4th definitely crosses the axis 4 times. Okay? So completely factor this thing. Well, I've got a pretty good hint to start. Both of these things work. So I'm going to put that 2 in to 1, 2, negative 7, negative 8, and 12. I've already done this work at the top of the page, so I know how it's going to go. I'm going to get 1, 4, 1, negative 6, and 0. That's one of my zeros. So now what do I know? I know that this is x minus 2 times. If that was x to the 4th, that's x to the 3rd plus 4x squared plus x minus 6. Now when I keep going, I'm going to put this negative 3 in, but I'm not going to put it in the original function like I did there. I'm going to put it in this x to the 3rd function and break that down further. You see how it's different. Okay, so I'm going to put a negative 3 in. If it was a 0 for the original, it's definitely going to be a 0 for that. So I go 1 for x to the 3rd, 4 for x squared, 1 for x, and negative 6 for the constant term. I know this is going to be a 0 because it worked for the big one. There's still an x plus 3 in there somewhere. So I bring down the 1, I multiply, I get negative 3. I add, I get 1. I multiply, I get negative 3. I add, I get negative 2. I multiply, I get 6. I told you there was a 0 right there. I have 2 zeros. So now I can say this is x minus 2, and it's times x plus 3, and look what I have here. That's an x squared. 1x squared plus 1x minus 2. That's factorable. I'm going to factor that. I'm going to stop with this nonsense. I'm going to stop with that nonsense. I can now factor that. So this factors itself into 2 sets of parentheses. There's an x to start so that I get x squared. The last ones have to multiply by 2. I'll put a 1 here and a 2 there. They have to be different signs, and they have to add up to 1x. So which one gets the plus? This one does, so that I'll have 2x minus 1x to give me my plus x. So I was asked to factor this polynomial. It factors to x minus 2, x plus 3, x minus 1, and x plus 2. The zeros are x equals 2, x equals negative 3, x equals 1, x equals negative 2. Check it out. 2 negatives and 2 positives. Just like my man Rene Descartes said, there would be 2 negatives and 2 positives. There you go. These are big problems, people. We got to do all the P over Q's to get a list to start with. We can go through Descartes' rule of signs to figure out if we can eliminate one of those to start working. We can use the upper bound and lower bound theorem to get rid of things once we start working. And sooner or later we'll find them. Sooner or later we'll factor it. Your homework will be on my math lab. Have a good day, everybody.